All right, gonna give this 30 more seconds if folks want to answer. And Ralph, I'm gonna have you go ahead and circle your
Oh
answer.
yeah. Let me let me grab an annotation here. So I'm gonna go with B, with the caveat that my head is between B and C, but I'm gonna go with B for a couple of reasons that we'll get to here in a second.
All right. Well, I am pleased to announce that you were correct, and a majority of the folks in the audience were correct, 57% to be
Okay.
exact.
Okay.
Um, but let's talk through this. So, where were you feeling torn between B and C?
So so all of these are for the most part potentially good solutions for a renovation generically. However, we're talking specifically about a historic structure that has specific details on its facade, which is brick, in the northeastern U.S. Right? It is
Right.
northeastern, yes. So just to kind of go down the list there, an EIFS system is a fairly good retrofit system with a couple of caveats. For really improving the energy efficiency of old masonry structures. However, when you do that, you're burying the masonry entirely. So it specifically talks about fine brick detailing in the question. So that's a clue to us that any solution that's going to be hiding that fine brick detailing is something that is less desirable. Again, from a thermal perspective, that's by far your best answer, but it's not a good answer for the historic details of this question. And another thing that you have to pay attention to when you're doing any kind of recladding is you've got to pay attention to how that secondary facade is going to perform in the case of fire. The Grenfell Towers that burned in the UK around 2016 were a case of a masonry structure that was reclad. The windows were set out into the new plane,
Mhm.
and so uh, you had a flammable insulation that was put with too large of an air gap, with the windows set out as well over the old masonry or concrete structure. And so you ended up with a situation where basically the facade made a chimney for itself,
Right.
um, which can be really disastrous really fast. Um, so, for a whole bunch of reasons, A is not the best answer here. And if you do choose A, it requires significant attention. Um, D is not the right answer for basically the same reasons as A. Again, fine brick detailing. Also, you'd rather put solar panels on a roof than a facade, generally speaking, because of how the sun moves in the sky. C is always a question, right? Low albedo, and I may be getting my albedos backwards here, but in my head, low albedo is high reflectivity, broadly speaking. Um, so it's a roof material that doesn't absorb a lot of energy. You do have to be careful when you retrofit those white roofs on older roof systems, because if they leak or aren't insulated properly, you can end up with condensation problems where the older black hot roof had enough vapor drive to dry to the interior even when there was heat or even when there was leakage. When you replace that old dark roof with a white roof that's highly reflective and doesn't absorb a lot of energy, you end up uh, you end up killing that moisture drive that you were able to have. And so there can be some issues with that you've got to pay attention to. And then you've got B. The reason I went with B is it specifically says There's the parking area in the rear of the structure that's scheduled to be demolished and redeveloped. If you're doing that, that means we're disturbing the ground already, which means that we would have an opportunity to install, there's space to install and an opportunity to install a geothermal system, whether the parking area is redeveloped with a conditioned structure or not. If it is redeveloped with a conditioned structure, then there's another opportunity to just really kind of bring everything together and have one system that is geothermal for the whole complex.
Right, and I'm gonna jump in a little bit and try to address some of the questions going on in the chat. Just so you know, albedo is measured 0 to 1, right? We can think about it as like like 0 to 100% or something like that. And low albedo is actually dark and not very reflective.
Well, so also a bad answer then.
Right, but I think where your head's at is right, and I think that there's some questions about what our scenario is. So I'm going to try with a trackpad to do a little axonometric drawing of our building with its, we could kind of say that this is our facade, and then back here is our parking area. Trackpad. And so, to be clear, the question is describing a feature, this southern facing facade with fine brick detailing, and a parking area which is scheduled to be demolished.
Yeah,
we're just taking pavement out,
basically.
Right. The question is not saying that we're demolishing any of our envelope.
Yeah.
And I think the question itself, I think the question itself is saying, we want to protect this, right? And we just want to select the sustainable strategy that is best. And so this affects our fine detail brickwork. This affects our fine detail brickwork kind of the same way. This is a little bit of a snag, right? If you aren't remembering whether you want low or high for reflectivity. And as NCARB says in their explanation, because you're already going to be digging up the paving structure, might as well, you'll have the equipment out there, right? Might as well dig a little bit deeper, dig some trenches, and install a geothermal system. I think also geothermal is something that comes up a lot in these exams that I don't think a lot of us are working with frequently. But it really is as simple as it sounds. You run the water through the earth and it helps temper it a bit, and you get some energy savings, right?
You could also drill a well too.
Right.
So if the parking lot's being redeveloped and we're putting a structure there, you wouldn't want to put the building over your geothermal if you can help it. I think that is strictly permitted, but you wouldn't want to put the geothermal over that if you can help it. But while all of that's being disturbed, you would have plenty of space to get a well drilling rig in and run the pipe and use a well system, which would occupy very little of the footprint back there that's being redeveloped. I mean, this sounds a lot like a typical, historic downtown structure that would have been built any time from, say, the 1870s to the 1930s or so.
Yeah. So great job, Ralph, and great job, attendees. We're going to move on to the next question.
And thank you all for correcting my albedo. I just drove 6 hours with minimal conditioning, and so remembering which way low is not where my head's at the moment. Got several fun, highly technical questions here today.
Of course. All right, Ralph, if you want to go ahead and start circling.
We're going to go with F. We're going to go with C. And I'm gonna go with, of all of the other options here, I'm gonna go with B.
Okay. So very close, Ralph. Um,
Mm-hmm.
the chat is correct. The
Okay.
poll is correct. And it was close. They were very, very close to also selecting B. I was kind of
Mm-hmm.
watching the horse race happen. And we can talk about this a little bit, but
Yeah.
where I saw this going and where I'll jump in is that in the question, the things that I see that jump out that I think are really important is
Mm-hmm.
possible hydrostatic, excuse me,
Yes.
possible hydrostatic water problems.
Yep.
That's significant. And
So is
so,
active canal.
right. And so, um, I think a common, stumbling block on the
Mm-hmm.
exam is when we're thinking about a significant moisture situation, wanting to have dam proofing when really our priority is anything that's going to move water away.
Mm-hmm.
So let's talk through your answers. I think it's consistent that is probably between A and B.
Mm-hmm.
Uh, and yeah, so what had you choose B over A? And can you speak to some of your other answers?
Yeah, so right, we're talking about hydrostatic pressure, which basically means liquid water pressing on the foundation, which is a right, that's a horizontal load. But it's also near an active canal, right, which means there is I'm picturing this area in my mind. And so the section is basically something like this, right? Where we have our building with its foundation, and then we have the canal with its water and what amounts to a dam between the two of them. Um, and so, obviously you want an aggregate base course or gravel field below the slabs because you need an area to collect the water there. And obviously you need drainage boards around the building because that's going to give the water a place to drop down
Right.
to your aggregate base course. Um, Now, the where my head went with sump pumps versus damp proofing, and damp proofing is obviously that's not going to really counter hydrostatic pressure properly, but in
Mm-hmm.
combination with a drainage board, now we can start to talk about something. But
Mm.
the reason that I didn't go with sump pumps is because it's an active canal, right? That's a large body of water. We don't want to be where my head went was you don't want to be pumping too much water out if the canal has a leak, kind of situation. Now, in the basement, right, obviously you would have to have a sump pump at the lowest parts of the foundation, basically once the building is constructed. But if we're talking about sump pumps during construction, that's something that I would think you would want to exercise some level of caution around. Um, that
I think that's a
said,
fair point, and I do think that that answer, the way that it's that answer option, the way that it is worded, is a bit
mm-hmm,
tricky, right?
mm-hmm,
Some pump near the areas where the footings will be constructed is that is not clearly defined if we're going to leave them there, we're
what's
installing them
the,
ahead of
yeah,
time, if there's any sort of throttling to be
mm-hmm,
done with the some pumps. I
yeah.
mean,
If you said sump pits, uh,
sure.
at the lowest points of the foundation, then that to me is a pretty obvious yes. But like on Michael talks about in the Amber Book course, um, one of the architecture buildings is mostly below grade, and when it was under construction, it's built on these large concrete piers that are drilled into the ground. Uh, and Blacksburg is in a karst area, limestone, heavily eroded, lots of caves. Um, and so when they were drilling one of these piers, they hit a void, basically, right, which is a cave. Um, and so as and it had water in it, and so as you do, they brought in a sump pump to pull that water out so that they could deal with it. And the issue there is that you can pull out too much water and you start destabilizing things. And so that's where my head almost immediately went here is well, if we're going to do this, I need a little bit more detail than they've given me here to be comfortable saying yes, let's do some kind of dewatering.
Yeah, I can appreciate that. I think what pops out to me is in the conversations that I've had with folks
Mm-hmm,
who have challenges with this exam, that a thought process like that might actually be a bit too specific
mm-hmm,
uh, in
mm-hmm.
in comparison to what you might see on the exam itself.
Yeah, yeah.
And so I think that the answers that are here are reminiscent
Mm-hmm.
to me of the differentiation NCARB or the ARE wants you to be able to make between
Yeah.
surface treatments and
Mm-hmm.
like full on water mitigation
Yeah.
strategies.
Yeah. 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 Totally. And like obviously vapor barriers are not the right answer because that's just talking about water vapor movement through like a wall section in the ground. That's not going to do you any good. Damp proofing, I can see damp proofing not being the right answer in that your aggregate base and your drainage boards are your first line of defense from the water coming through the soil toward your foundation. It's going to hit those air pockets and drop down. Um, so I can see sump pumps for sure.
Yeah. All right. Okay, Doke. Let's give the third one a try. So I would say the audience is 2 of 2 and Ralph is 1 of 2. Here we go. I included a graphic this time,
Ooh,
a groundbreaking
we like a soil boring
experience.
log.
Yeah, we're innovating here at Amber Book. Also, we're about 2 minutes in to answering this question, and I've gotten word from headquarters that the audience actually picked A, B, and C last question, and not those were the 3 majority answers. So updating the score here, it's tied
Mm-hmm.
with
Well,
both the audience.
I'm fairly confident I'm going to get this one right. So
Well, that's good.
trucking
This one's a bit close, so we'll see.
right along. Let's see if they can beat me.
Right. All right, Ralph, let's have you go ahead and
Answer
select your answer.
done.
Okay. I'm gonna end the poll, share the results. You're
Mm.
consistent with the chat,
Mm-hmm.
but the
But
answer is Matt
Matt,
Foundation.
interesting. I'm less
Would
familiar
you
with mats.
would you like me to
Um,
explain the logic there?
well, just explain what a mat foundation is, and I'll probably be good.
Continuous slab for the entire footprint of the building.
Okay.
I think the distinction here, right, is that a mat or a raft
Mm-hmm.
foundation is how we think about a slab on grade, right?
Mm-hmm.
Those two are actually the same thing, right? They're not
But
different,
like they're a little different.
but sure, in how they're executed for sure,
Yeah.
given
Yeah.
that you're anticipating different loading.
Mm-hmm.
But it's essentially a slab on grade dropped down to where you want it to be.
Yeah.
And
Yeah. So that it becomes
I'll,
basically a boat.
it's basically a boat. And the idea here that I'll share is that when we don't have any seriously competent soil through our entire
Mm-hmm.
boring log.
Mm-hmm.
And it seems like
It's
folks
all
want to talk.
garbage. All of
Right,
this soil is not good bearing soil, but it's also a
right,
parking garage, which has fairly high load per square foot requirements relative to like a
true,
house, for example.
true.
Um,
So the idea here is that we're essentially going to have our load spread as evenly as possible
mm-hmm.
over a giant
Yeah.
foundation pad. And the other thing here that's a little bit of a wrinkle is that the question is not just asking most appropriate, but it's also asking cost effective. And these mat foundations, they're shallow, just like we know slabs on grades to be. They're uniform, and unlike uh, piers or piles, we're not having to use any specialty equipment or do a
Mm-hmm.
whole
Mm-hmm.
lot of
Well,
tying in,
yeah, it's the tying in and consolidating, right, that gets you in trouble,
right,
especially in a parking garage where you can have really irregular loading conditions, right? Somebody brings their truck down that has a load of gravel in the back end and parks it for a week.
right,
That's going to be different from, four Mini Coopers,
right,
right? Like I can think of a place in Blacksburg where there's a parking lot, and there's a dumpster in the parking lot, and there are ruts in the asphalt that are 2 or 3 feet deep from where the truck backs in, and that's where the truck's back tires go when it picks up the dumpster every time. A
right,
mat foundation should help mitigate that kind of situation so that, because we have, again, garbage soil here, so that we aren't dealing with sinking, right? San Marco in Venice is on piles, right?
yeah,
Wooden stakes driven into resistance. And over the 600 or so years, 700 years of its existence, the floor has a bunch of waves in it. And when we're talking about a floor to floor height of 10.5 feet, if our building starts to, settle unevenly across those piles because one pile is in some soil that's rougher than others, then we end up with trouble, right? Piers bear on a hard substrate, is my understanding of the difference in where piles are driven in bad
mm-hmm,
soil to resistance. So we have no soil here in our soil chart that a pier foundation could bear on. So
right,
that leaves you with mat, pile, and slab. Slab on grade is no good because we're not on grade, we're under grade.
right,
And then mat in this particular case is better than pile because the mat foundation is better able to handle the irregular loads of the particular situation we're in. Also, if the mat foundation is a bit of a boat, we were asking about where the water tables are.
right,
So this soil boring log shows two. One is the black triangle at 10 feet. The other is the white triangle at 14 feet. One of those is the where liquid water was basically hit initially in the drill.
right,
And then the other one is where water was at after 24 hours. I forget which is which offhand. But the black
right,
triangle is above 10.5 feet, right? So that means at least the last half of a foot is in an area that may have some water problems sometimes.
right, right. And maybe you can speak to, I know there were some questions in the chat about how you go about reading this. Could you just kind of go left to right and read this report?
Yeah. All right. So going from left to right, we start out with an elevation column, which starts at 0 and then goes down. The numbers on the right are probably the elevation above sea level,
Right,
right? So 695 feet, 690 feet as you go down. Next, you have the water table. Below that, or after that, you've got the soil types and like where those transitions happen. I'm not 100% sure what the 7.65646 to the right of that is, but it's
mm-hmm,
probably like a lot of these soil tests measure some level of the soil's resistance.
mm-hmm,
Um, And so that's probably 7 somethings in 6 inches, if I had to guess. Now I don't know what this what that 7 is measuring, whether it's 7, it's not 7 standard hammer blows. I don't think this soil is not the type of soil that would be that level of resistive.
Mm-hmm.
But it's possible. And then uh, you have the soil classification.
Mm-hmm.
So CL is clay, SC is sandy clay, CL at the bottom is clay again. I forget exactly what SM and OL are, but those abbreviations are standard in soil science. And then you have a description of the soils that's kind of written out. What are they like? That kind of thing. And then of course you have the project, when it was done, what the top level, what the zero elevation is. Yeah, so I can say conclusively those 600
Right.
numbers are elevation above sea level, because there's your elevation. The location of the boring, and like where the boring, which boring that boring is on the plat.
Mm-hmm.
Um, and then it does say that that was a 6-inch hollow stem auger. And we have no record of water depth check, or where like caving, I think, is we hit a cavity, et cetera, et cetera.
Right. And I'd say often when we think about how we read soil boring logs for these exams, not often will you be tested on this
Yeah,
information on the right as much as you will on the information on the left.
you're looking for, as we were asked here, like where's the water, and then what does the different types of soil tell you about the building that the building you're looking to put there, right? So
Exactly.
if they hit limestone at 9 feet, right, we're looking at, okay, we're going to have to blast if we want a 10.5 foot ceiling, or we need to rethink our building and
Right.
not have the parking structure hit quite so low.
Sure. Exactly. Excellent. All right. Let's keep it moving. Going to move on to the next question.
Woo.
All right, Ralph, let's have you circle your
Have a
answers.
go. Yeah.
Yep.
So I would say for sure this, and for sure this, because you want to avoid any potential hiccups. And I'm now between the full pricing set and the pre-application meeting. It seems like this is a situation where there's some level of zoning approval already. So I'm going to go with the pricing set.
Okay. And the results are that the audience did really well.
Oh, good.
Got them all right with a significant majority. And you were close. You were really
2 out of
close.
3 again, right?
2 out of 3. And of course, that's what's so
Uh-huh.
tough about these questions. Um, but if I can start with some, you know, mind setting, right?
Yeah.
The idea here, I think, is that I think the question that we're being asked is what can we do while the ducks are getting in a row?
Mm-hmm.
And the other portion of this is that the ducks getting in the row, acquiring the 3 remaining lots, that's completely out of our control.
Mm-hmm.
Um, and so completing a full pricing set through the eyes of
Puts the cart
the
ahead of the horse a little bit.
it's risky. It's risky
Yeah.
because that's a
Yeah.
lot of work. Full
Well,
pricing set, a lot of work.
the further along that development looks on paper, the more your remaining owners are going to put the screws on the developer as well.
Sure, sure,
You
sure,
know, we are very familiar with the photos of spite houses and that sort of thing, right? Those last few lots can get really expensive,
sure.
unless you do what like Rockefeller did when acquiring Williamsburg, or what Vanderbilt did around Asheville when he was assembling the Biltmore estate, and have a third party basically go around and buy up everything under a different name, so that it's not known who's actually doing the buying. Don't do that. That's sketchy, but that is what was done historically pretty often.
Sure.
Obviously, B is great, because if you do a project like this and don't talk to the neighborhood beforehand, wrenches get thrown at you immediately, which gums up the works pretty badly. Where I'm at here locally, there's a project like that where the folks that are looking to develop it didn't communicate appropriately ahead of time, and it has been stalled significantly since then because folks got a little frustrated, shall we say. And a little communication there goes a really long way, usually, and you get to know who you need to talk to and all that kind of thing. Coordinating the details of the bus stop obviously covers you from going out to design something that's not going to work. So you know what the boundaries are for that particular aspect of the project. And then F, of course, is a better answer than A, because you want to be in communication with your planning and zoning departments as early as possible, so that you know what the process is, what things you're going to have, and that kind of thing, so that it is most likely when you make your initial submission, there will be as few as possible things that need to be corrected for final approval.
Right. I think
soil
now,
tests are early, are because not all the lots have been acquired yet,
yep.
and you're not going to be able to do soil tests on the lots that haven't been done yet. And of course, if you delay everything until after all the parcels are purchased, then you potentially are really slowing things down, and it may be that the owner's not going to be able to purchase all of the parcels.
Sure. Again, the way to look at this question is, what can we do while we wait, so to speak? And I think the other thing to keep in mind is that the focus of the question is not that broad. It's specifically, what can we be doing in order to secure the incentives?
Yeah.
And
which
so,
is get construction started in a year. Well, it may be that, okay, we can get planning approval for enough of it to get construction started, and then we end up phasing the project from a design perspective.
right, and the commonality between B, D, and F is they are all things that could slow down the project when we think about starting construction in a year. So could C, right? That could slow down us getting the project done in a year, but in a completely different way. And also is not really working towards our goal of securing the incentives.
Yeah, that works against the goal of securing the incentives.
Right. Completing a full pricing set of drawings is of this spirit, right? We need to get this thing moving. But we can do, I mean, I'm reaching here a little bit, but we can get that done to get to a place where we can start construction. The things that are a bit out of our control that we want to initiate, again, are meeting with the neighbors, coordinating with the transportation authority, and coordinating with the city.
Yeah.
So
a famous, and again, the owner may, or the developer may never be able to acquire all of them. I mean, famously, I think it's Magnolia Bakery that's right next to Rockefeller Center, is a like 3-story brick structure that when Rockefeller Center was being planned and then constructed, was not able to be bought by the Rockefellers at the time, and so is still there.
Wow. All right. So far the audience is 2 of 4, and Ralph is 1 of 4. Going into our last question. Here we go. Also, I was cruel this week, giving a lot of pick 3.
Yeah,
that apply.
Those will always get you.
But I think they're worth the practice.
Oh yeah, no, they're great. And they let us talk through a few more things. Excuse me.
How are you feeling about this one, Ralph?
Okay, there's a couple of these that I'll say, not immediately familiar with right off the top of my head because I don't deal with them very often.
Right.
But you think about what the Southwest is like and how different materials behave when they're exposed to those conditions, and you can start to put together a few things.
All right. Why don't you go ahead and select your answers?
I'm going to grab those three.
Those three. Okay. And I'm going to end the poll.
Although one of those is not technically a passive cooling strategy, sort of.
Right.
So.
Great catch. Great catch. The thing is that your answer is consistent with the audience.
Yeah. So I would
And
probably swap, if I were thinking about that a little more closely, I'd probably swap C for B, but I circled the three, so we'll go with the three.
yep, we'll hold you to it. The correct answer is A.
Fascinating.
And the point here, and we'll see if the chat wants to correct me, though I think we're all on the same page here. Trom
Mm-hmm.
walls are a heating strategy
Mm-hmm.
because it's
It's a big
the
mass that you intentionally overheat, right?
you put in
That
you take a thermal mass and you put it inside a greenhouse.
Yeah, yeah.
Yeah,
So you're putting lots of glass on your south wall, and you're putting this. It could be water tanks, it could be a large masonry wall, and you're painting it black to soak in as much heat as possible in the day inside the building.
right. We see trom walls in Northern California, for
Yeah,
example.
yeah.
Um,
A little too
the
hot
system you just
down
described,
here.
yeah. So the other thing is that you started to say this as soon as I ended the poll, but
Mm-hmm.
again, passive cooling
Passive cooling.
strategies,
Yeah, and
mechanical cooling.
mm-hmm. That's the
Eh,
trouble.
eh,
Um,
no,
Yeah. So thinking about, and admittedly, roof ponds is never something that like would give me the warm fuzzies.
right,
Putting a bunch of water, but that is basically the passive version of the swamp cooler, which is what C is.
yes,
Um,
yes,
so you know, well, A and D really both are the passive version of the swamp cooler that is what C is. Although you could make an argument that if you're pumping water, excuse me, if you're pumping water for the fountains, how passive is that actually? Um, if we're gonna really, because if we want to really be picky, um, I won't hold NCARB to or us to be quite that detailed, um, but yeah, materials with a high thermal mass in the desert Southwest, you have really high temperatures in the day and relatively cool temperatures at night. So if you have enough thermal mass, you can delay the heating cycle so that it never really gets that hot inside in the day, and it never gets really that cold at night. You basically turn the building into a cave.
right,
Courtyards with fountains provide the same kind of cooling that a swamp cooler is going to give you. They're gonna add moisture to the air, which lowers the temperature. That's an enthalpy thing, if I'm remembering my physics terms correctly. But your psychrometric chart will tell you all about that. You're basically raising the humidity, the absolute humidity of the air, uh, so that you lower the temperature. And then roof ponds are going to do something similar to that as well. Maybe I don't know, and I don't know if roof ponds are meant to behave more so as a thermal mass or more so as as an evaporative cooling situation.
Right. I think there's a lot of great discussion going on in the chat right now about the viability of some of these strategies. I think the
Yeah, roof
best
ponds
point
don't, like I
is,
said, roof ponds don't give me the warm fuzzies.
well, that, and that's because you're familiar with the Southeast, but and have concern moisture, different kinds of moisture
Yeah.
concerns. But I think the consistent point here is that it's hot and it's arid. Where's all this water coming from?
Also that, yeah, yeah.
And
A
and
fountain
what I
is going
want
to use a
to
lot less water than a roof pond, too.
exactly, but what I want to zoom out and kind of emphasize here is that, like other types of questions on the exam, I think
Mm-hmm.
it's as you're studying, as you're practicing, developing a way, an internal kind of dialogue about how to read
Mm-hmm.
these questions. What is this question asking me? What is this question asking me? It's asking me about passive cooling
Mm-hmm.
strategies. It's giving me an environmental context. It's
Yeah.
not asking, it's not saying what's the most sustainable option, right? I think
Mm-hmm.
oftentimes we are holding a lot of information around these kinds of
Yeah.
situations where it's really hard to ignore some of them and not think about it holistically. But
Mm-hmm.
oftentimes these questions are asking something quite specific.
Yeah.
And the more that you can drill in on what the
Mm-hmm.
question is actually asking, and unfortunately divorce yourself a little bit from your critical
Some of,
lens,
yeah.
I
And
think that that's an important part of what I would call
mm-hmm.
problem
Well,
solving on these
and
exams.
you're ultimately being asked to pick three answers, so you know that there are three that are definitely not it and three that are definitely it.
Right,
And so just going through this, large windows to the east and west are going to heat the building, not cool it.
right,
Unless you're in a site where those large windows are open most of the time for breezes, maybe. But you're in the
right,
desert Southwest, you want to keep the hot air out in the day, not be letting it in. Breezes,
right,
unconditioned breezes, don't do that much for you.
right,
Materials with high thermal mass, that's adobe. We do that all day long in New Mexico, Arizona. Um, that's a historic building material that works very well. And again, you basically build an above ground cave at that point, and so that
sure,
has a mediating effect on the temperature. um Courtyards with fountains in the lower portion of Spain, Granada, Valencia, that sort of thing. There's a long history of courtyard houses. You put a little teeny tiny fountain in the middle of it and have 4 or 5 stories, and you have an entryway, and or even 2 or 3 stories is enough. But and an entryway to funnel air in. Air gets sucked in, hot air goes out the top, and the air is cooled by that fountain in the middle because it's so dry that adding just a little bit of moisture will lower your temperature, I don't know, 10 degrees, 15 degrees,
right,
something like that. This is another one of the things that a psychrometric chart could tell you exactly how much.
right,
Um, Evaporative mechanical cooling is not passive. A trom wall is a heating strategy. So that means that roof ponds are the only available choice. They're a
right,
weird choice,
right.
but they're the only other available choice that meets the criteria
Exactly. And that's what
in
I
any
would,
sense of the word.
and that way of thinking about it, that way of breaking down the question is exactly how I'd
Yeah,
recommend
yeah,
trying to think about these
yep.
questions, is not getting too caught up in what would be the like holistic side quest,
Mm-hmm.
and really just trying to stick to what the question is asking itself, right? I think about this, I like to talk about this a lot, is like in parallel to a driving license exam. You're just trying to give the answer that stop at the stoplight, use your turn signal, not follow too closely behind, rather than talk about how to navigate a drive from New Hampshire to Louisiana
Mm-hmm.
uh, during a blizzard, let's say.
Yeah.
So, where in that case, right, when we talk about conceptual minimally competent and compare it to specific and applied,
Mm-hmm.
sometimes these things change, and that's the nature
Mm-hmm.
of things.
Mm-hmm.
Sometimes the rules change, the
Yeah.
guiding,
Yeah.
the
But here you're
the
given
bumpers.
but here you're given a set of criteria and you have to eliminate the bad answers and identify the good answers, basically, right? You want to eliminate the incorrect ones and then identify the correct ones and work toward the middle that way. And so in this case, like if I'm thinking through it closely, excuse me, I don't pick roof ponds as a best answer until I've eliminated the three answers that are definitely not correct.
Right. Exactly. And I would agree with that too. Uh, it's it's asking a question that will take sort of simply which of the following, well, I'm gonna stop there. It's
Yeah.
not the best question. I think we can all agree on that.
Mm-hmm.
This is these situations are really nuanced. Also,
Yeah.
this is the thing too about some of these sustainability related things like passive
Mm-hmm.
heating and cooling. They're not in some situations not the end all be all. Oftentimes we're
Mm-hmm.
supplementing them. They're
Yeah.
helping us get to our goal. We could think about it like more often than not, going back to the car thing,
Mm-hmm.
we're more often than not, we're building hybrids rather than
Mm-hmm.
full EVs, right?
Yeah. Well, and this is also where your psychrometric chart comes back in. We can think of those comfort zones and how we can achieve comfort for, however large of a temperature range we're dealing with simply by adding new strategies until we've covered all of the possible outdoor temperature conditions, right?
Yep, exactly. Yeah, so let's go ahead and just open it up if anyone has any questions. I know we've gone quite over the time. It seems like folks are on their way out, which is totally fine. But yeah, if there's any questions, go ahead and raise your hand or pop them in the chat right now. I'll try to keep an eye out.
But yeah, I'll just say roof ponds are a weird one because putting a big bunch of water on your roof means that you've got to seal your roof really
Oh,
well, right, to
absolutely.
keep leaks
Absolutely.
out. Um,
Okay, we have a question. Here we go.
Hi, how are you?
Good.
Good, how are you?
Good, thank you. Thank you for the question. That was very good for our design, like study and preparation for the exam. I have a question about life cycle cost analysis and the life cycle analysis, and how does it relate to things like embodied energy and sustainability, like when we take account like where do we take account the transportation, where do we take account like for salvaging the equipment or like the material after like we use it for like 20 or 10 years or whatever. So can you just expand a little bit more like what we take in consideration for like life cycle cost analysis and life cycle analysis in terms like embedded energy and sustainability?
I can kick that off. The thing to think about, the difference between the two, which are unfortunately named
Super
quite
close together.
similarly, and I would think too that Ralph, thinking about this study that we've been doing on advanced
Mm-hmm.
framing, how
Mm-hmm.
the naming will probably change over time because
Yeah.
folks it is confusing, right? Life cycle analysis is focusing on the environmental impacts of whatever it is that we're doing with the building, thinking about it holistically, right? It's carbon footprint from supply, installation, and
The
um,
works.
the works. It's a sustainability tool. Life cycle cost analysis is a bit more focused on the economic impacts of what we're doing. More so, what's the cost of operation? What's the cost of installation? And it's a way of evaluating if a decision we're making today. So I saw a really great talk at the AIA conference with two architects from Olson Kundig presenting a project that they worked on with a developer in the Bay Area, where they were making some decisions about, was the investment today worth the return in 10 years, right? And so both life cycle analysis and life cycle cost analysis are both ways to think about what are we doing today and its broader long-term impact. One, which has cost in the name, is more focused on cost, and life cycle analysis is more focused on sustainability and that sort of thing.
So which one more like we consider like transportation or like shipping in material from like different like different places or like far places, or both of them we can consider that?
I think they both factor in. It's more, is the is shipping in a specific material. Like, let's talk about cross-laminated timber. In the US, we are starting to build up our infrastructure for that, but in Europe, for example, they're making some great stuff. I've never actually seen it, but I get the impression that it's great.
They are.
So
in the US, it's made like in a couple of places in the Southeast,
right,
and a couple of places in the Pacific Northwest, and that's kind of
right.
it.
So from a life cycle cost analysis, is shipping it over from Europe, is that additional shipping cost worth a higher quality product, for example? With the life cycle analysis, is the transportation, is the shipping of those panels across the Atlantic having such a significant carbon footprint that it's almost negating the use of that material over something
more locally available,
Yeah.
right?
Or available with a less impactful transportation mode.
Right. That's how I think about it. All of it is in play when we're thinking about life cycle. It's more just what's the lens you're looking at it through. I've got some questions in the chat. One, do we consider the trom wall a thermal mass material?
I mean, trom walls are using thermal mass. To store energy to heat the building. Yes. I don't think they're generally used as a cooling strategy, right? Because it's kind of hard to, how do you get the energy out, basically becomes the issue.
Right.
But it's a lot easier to have a big south facing window and get solar insulation that way to heat the trom wall.
Right. So we're going to have a roof and some glazing in the trom wall. That's our trom wall. And so we've got light coming in during the day, or UV coming in during the day. This trom wall is a thermal mass. It's absorbing that heat and it's storing it. And then when our light goes away, oops, when our light goes away, the heat then is able to radiate out, right? Because we know in physics, we're trying to reach equilibrium. Not we, but
the energy.
Yeah, energy is trying to reach equilibrium. And this is why I know that there are a few different things in the chat about trom walls also being a cooling strategy. But again, from my perspective and experience, oopsie.
The physics doesn't really work. It doesn't want to go that way.
Yeah, it's way more a heating strategy. Yeah, and then one more from the chat, just about, could you give some typical examples for each foundation type?
Like use cases, I assume.
I think we can talk a little bit about, I'm distracted here. I think we can talk a little bit about how I'll go back to our question. Too far. Okay.
There we go.
For me, if you've ever been to a beachy area, especially those with, let's say, erosion concerns and sandy soils, you'll see pile foundations. That's for me, the easiest analog is we take essentially a telephone pole and drive it down into the
into the
ground.
ground. Yeah. And you can do
and
a similar thing with concrete. It's just a little trickier. There are also steel driven piles.
right.
But yeah, you take your telephone pole and you drive it into the ground until basically it stops.
Yeah.
Until the resistance of the soil against the pile is greater than the force you're applying to the top of it. And you size that force based on what load you're going to put on the pile later.
Right. And thinking about piers, Ralph mentioned this, but a pier is something that is maybe could be a similar process, but it's something we're driving down to competent soil.
Or
It's
bedrock.
making or bedrock. It's making a direct contact.
It's not a frictional bearing. It's a point bearing.
Exactly.
Slab on grade is for
Yep.
fairly light duty buildings, houses, and I think some warehouses will be slab on grade, like the single story ones.
Absolutely.
Especially. Yeah.
Absolutely.
Relatively light load for the size of the building. And then your mat foundations are for like soggy soils that are not competent, because a slab on grade foundation typically doesn't have very much capacity to span like a bad pocket of soil.
Right.
So your mat foundations come into play when you're doing a basement, especially in an area that's a little swampy or a little clayey, or in cases where you've got fairly high loads in a more kind of surface condition, is my understanding.
Right. So hopefully that is a little more detail. I think we can call it there. Thanks everyone for joining us this evening, and thanks to all those who stuck around. We will be back next month and do this thing again with some different questions.
I might have to study a little beforehand this time.
Right. Well, I think it's good that you acknowledged your long drive beforehand. That plays a role.
Well, and
don't drive for a long time before you take your exam, right?
Well, a lot of these questions are really reliant on you knowing some specific, basically, piece of vocabulary.
Yeah.
And so, like, I'd not touched trom walls in a hot second. So, the last time I touched them was, early morning before they'd had a chance to heat up. So, needless to say, it took me a minute to remember what those were.
Yep.
Along with, a little prodding.
Right. Right. All right. Thanks, everybody.
Good night and good luck.
Yep.
Get licensed.
Get licensed.